Today we're going to simulate lightning in Blender using geometry nodes. So see here I have a lightning asset, a very nice asset actually. You can change the seed. You have a different lightning bolt each time. For example, this one here is pretty cool, and you can also make it grow and shrink. So if you have 0 here, this is invisible, and you can just add more of those values and it starts to grow like that. So this is pretty cool, right? So let's start making this, and if you're interested in those clouds you see in the intro, then you can check out Patreon. I have a tutorial on how to make those clouds in Eevee. So let's start. First, what we need is an object, or actually a reference first. So we have a reference here and also the asset. I'm going to move the asset here, and we first need an object to add those geometry nodes onto. So let's add a monkey. Let's add a cube actually. But the first thing that we are going to do is the middle branch here, the most massive one. And as you see in this asset, this is also the most massive one. So kind of like a job well done, right? So let's add a geometry node set called massive branch. And now we basically need a line that is very wiggly. So how do we create a wiggly line? Well, we first obviously need a line. So let's search for a line. For example, mesh line or curve line. Now the problem with mesh line is that you cannot make it thicker afterwards, it just stays the same. But with curves you can do some fancy stuff with radiuses and all that stuff, so we need curves to actually make this thing have some thickness, you know. So first let's disconnect those, and let's make this lightning a bit longer, so for about as much as we see here. Now what we need to do is to randomize it, because this is very straight. So let's add an object, an attribute randomization nodes, and put it here. I also forgot to say that you need Blender 3.0 for this thing here, so make sure to download the alpha, or when it's out, beta or gamma or whatever. So we're gonna randomize the position of this curve, and not just of this curve, but the points that make up this curve. So if I have a spreadsheet here, for example, spreadsheet, then you see that when I click Ctrl+Shift-click here, I can see control points, and right now our curve has 2 control points, right? So this isn't too much. And as you see, we have not anything good here. So this has 2 reasons, and the first reason is that this is a float randomization, and also we are creating a whole new position for each point. So let's first do so that we switch it to vector. So now you randomize a vector, and you don't essentially see a good improvement here, but that's because we have still only 2 points. So let's add a resample curve node to have more points. You can add a subdivision, but length works better here. You can see why in a minute. Basically, let's add 1.5 meters of after each 1.5 meters, you're gonna have another new point. So this means we now have like a little random ball here, and we have to make it straight. So for that, we just are gonna switch the replace and create thing here to addition. So we're gonna add a random vector to each of those points, and we have something like that. This is like the first detail level of this lightning bolt, right? So let's delete this one, and let's add some more randomization. So how do we do that? Well, we just resample this once more, but this time with a smaller resolution, so for about 0.5 this time, and let's add another randomization. Now the randomization, okay, is a bit better, but this is too much. So let's just do so that we go here, and the maximum is let's say 0.5 instead. So this is better right now. And let's add one last level of a detail with the resolution of 0.2 and another randomization node, so that we have even more details. And of course the randomization has to be a bit softer, so maybe something like that, maybe a 0.5, something like that. Okay, this is the basis of our lightning bolt. Now let's add a control for this asset. So as you see with this one here, we can change the seed value, and we have a whole lot of lightning bolts. This one is ugly, this one was pretty cool. And we can do the same thing here, of course. So we're just going to take the group input, which is our control base, and let's drag to this seed, and also to the seed, and you guessed it right, also to the last seed. So now we can change the seed value here, and we have different lightning bolts that are all very random. So this step is done. Now the next thing we have to do is to add the middle branches. So how do we do that? Well, we just duplicate this object. Let's call this one here the massive branch. And also let's add the middle branch and this smallest branch. So this is basically going to work in a way that, you know, for example, this here is the main branch, biggest one, the most massive one. And this one here is the middle one from here. And these small ones here are the smallest ones. So let's rename those accordingly. This one here is middle and also the small one. Now what we're going to do is that we're going to instance the small thing on the middle thing and then the middle thing alongside with the small ones on the massive one. But Blender is very crashy right now, so we have to be very careful doing that. So let's select the middle one here and let's add a set of geometry nodes called middle and also a set of geometry nodes called small. So each one of those has a different set of geometry nodes right now, so they don't, I mean, if I change something here, this hasn't changed here in any ways. So select the middle one here and let's add a point instance node. And be careful now because this is gonna crash probably if you do something wrong. So let's take the node and put it here. Don't connect it yet. Turn this node off, put it here. Make sure it is turned off, right, with M key, and select the small object. And only now you can turn this on. If you do this like before, then it's gonna crash. Make sure it is turned off most of the time, right? Except for the visualization. So we have a lot of those small branches appearing on the curve here, which looks kind of cool, but isn't very necessary for us. So what we're going to do is that we are going to make sure that we have a certain number of them by using a curve to points node. So curve to points and put it here. So now we have 10 small branches on one middle branch, right? This is good and all, but actually we have lost the middle branch. So why is that so? Well, that's because the middle branch is here and here we turn this into points and then the instances. So we just have to join those together. So let's use join geometry, put it here, and let's connect this one from here to there. And look at that, we have this center thing here. Obviously, you notice the problem that they are not starting from the center object. They're very random. And you know, randomness is good when making something like that, but this doesn't look very believable. So let's turn off this point instance because we're going to manipulate this small thing here. So the problem why they were offset is that the center point of the object is here, not in the center here, or in the starting point of the lightning bolt. So let's fix that by using a transform node. So transform, let's move this on the x-axis and also on the z-axis. And also moving on the y-axis is also very good. And we have it fixed, right? So now let's go back to the middle one and let's select this point instance and turn this back on. So now they're all starting from the center, which is very good. Now what we need to do is to randomize their rotation and scale, of course, because this is looking very like the opposite of random. So let's do that by using a randomization node and randomization attribute randomize. And let's randomize, for example, let's randomize the scale first. So you type in here scale and this is basically everything you have to do. Just scale and maybe 0.9 here so that they're not so big. And we have a pretty nice looking thing. Actually, I'm going to turn off this point instance now and I'm going to change the seed of this thing here because this is exactly similar to the middle one. So I'm just going to put like, let's say 3070 here, not 8070, which is the graphics card I just got. But I don't have this yet. I cannot use this yet because my CPU hasn't arrived yet. That's for the information. Somebody asked me about the performance in Blender. Anyways, we can go back here and now turn this back on. And as you see, they're different than the main branch right now. And we're going to also randomize the rotation of them. So let's take this thing here and let's randomize the rotation, which is a vector attribute. So because this is a vector attribute, let's use a vector as the randomization way. So this is now looking like that. And this isn't very good because, you know, the maximum rotation is only 1 radian on all axes right now. And this means 57 degrees. So obviously we need more. We need 360 degrees. So let's go here and write here tau, which means 2 pi, which means in radians 360 degrees, right? This is looking very random right now. And this is good, but we have to just make sure they point upwards, right? Or in one direction, actually, at least. So let's use a vector align node, align rotation to vector node, put it here. And let's select the direction where we want them to look at. For example, upwards, right? This makes sense. Upwards, there is the z-axis, as you see here. So let's use a number on the z-axis. For example, I don't know, 20, because I just got 20 years old, by the way, 21 days ago, something like that. So let's select an appropriate axis also, for example, Z. So another pointing all upwards, and this is very good, but this is, you know, very strict. So let's slide it to I think for about 6 to works well here. And this is pretty good, at least that's what I think. I'm also going to decrease the number a bit because 10 is a bit too much for those. So let's make sure, oh, this looks kind of like the hair of Bob Ross. Anyways, let's make sure we have 7 here, maybe. Yeah, this seems good. And let's add some randomization controls for those branches. So let's go here and select the seed and the seed of the rotation also. And now if you change the seed here, we have a whole lot of different lightning bolts. All right, so this is pretty cool. But now what we are going to do is that we're going to instance this middle thing here on top of the main massive branch here. But we cannot do this directly because Blender is going to crash probably. So instead, what we're going to do is that we are going to create a collection of different branches like that. So for example, let me show you what I mean. Here in this original asset, we have a collection of point instance of the middle ones, and this is a collection that is instanced on the original one. So we just have to have the same thing basically. So let's duplicate this thing here, but first I want to move this thing here away, this small thing here. So if I want to do this, I have to turn off the point instance first, and only now I can move this. If I keep this point instance enabled, this is going to crash Blender. So I'm going to move this somewhere there. And now I'm going to go back here. I'm going to enable this again, and I'm going to duplicate 3 times the thing here. You can add 5 of those, doesn't matter too much, but 3 is like a good and tested number. So let's add 3 different variations of them, and let's convert them to a mesh so that we can get rid of the geometry nodes. So if you just enable or just apply the modifier here, this means that, you know, we only actually get the cube here, down here, you know. So we don't want it, we want the curve data from here. And you also cannot just go to objects and convert this into a mesh like that, because this is also going to get rid of those. It's going to keep the original thing here. What we have to do is that we are going to use a curve to mesh node first. So curve to mesh, put it here. And now this is a mesh. And also those 3 are meshes. And what we can do is that we can just go to object, convert to mesh. And now we have gotten rid of geometry nodes. This is a thing made out of vertices. So very good. And let's go here and let's add a different variation, something like maybe that. Select object, convert to mesh. And this is a mesh now. And also for the last one, I'm just gonna take down the count a bit so that we have a little less there. Maybe something like that, maybe even lesser. I'm going to convert to object, convert mesh. Now these are all meshes, and we can delete this smallest one here. We don't need this anymore. And I'm going to add a new collection of those. So let's add a new collection here. So I'm going to go up here and let's add a new collection called collection 3 right now, but let's call this middle branches, and let's move those 3 middle branches inside of this collection. Right, so now this is working well. And let's go here and let's, I'm going to hide those actually right now. Let's go here and instance those on this branch here so that we can have an asset that looks, you know, like that and can be changed randomly. Let's go here and let's add a point instance node. So point instance, put it here, turn it off, put it back here, and select a collection here. Make sure the collection is middle branches and turn this back on. And as you see, we just have 3 branches here right now. So why do we have this? That's because the whole collection is enabled. So let's turn this off. And you see here we have something, but this isn't very good. This doesn't look like a lightning bolt, and that's because we are not using the curve to points node. So let's use a curve to what? Curve to points. And you know, here you see we have something, and yeah, we have also lost the middle one, so like the core branch. So let's use a join geometry node, put it here, attribute randomize, drag it here, and we have the middle one back there. Right, but they're also very offset here, which was the case with last time. the last time. So let's turn off this point instance and let's fix the origin points of those middle branches. So let's enable the visibility. Let's go to the edit mode because they're meshes right now. It's easy. And let's move them for about here. This one to maybe here. And the last one to here. So now they're all correct. And let's go and hide them again to make this thing a bit more visible. It doesn't look very good. So instead what we're going to do is that we're going to add a controller, basically. So the controller works in a way that we have right now 10 points on the main branch, right? So what I want to do is to select randomly 5 of them, or 6, depends on how much I want, and instance random branches on them. So how do I do this? Well, if I have 4 points, I'm going to give a random value to each one of those from the range of 0 to 1. So now if I have a threshold of 0.5, then I can just, eliminate the points that have lower values. So for example, this one here, and also this one here. But if I change the random attribute and have different numbers, then I can have different points selected, of course. So what I'm going to do is first add a randomize node to create this random attribute, to give each one of those points a random value. So let's select, what is it, position? No, we have to create a new attribute, right? So let's call this a random number. And I have a space in there. Yes, I know that, but it seems to work. So let's put it here, random number. And let's now compare the random number to a threshold using an attribute math node. So attribute math, put it here. And let's use a greater than also here. And let's compare the random number to a threshold of float, resulting in an attribute called selection. So now we have an attribute, a selection attribute for each one of those, and you can see how it works. So if I go to this thing here, you see we have a selection of 1, which means selected, and 0, not selected. So let's put the threshold to 0.5, and we have more of points selected right now. And we just have to add a node that separates the points based on the selection. And let's use point separate. So this takes the geometry points and masks them or separates them based on an attribute, which in our case is the selection. And now I change the random attribute. We have different locations for different lightning bolts, right? But among those 10 points, we don't change the amount of points, we just change the seed of where they are going to be instanced. So I'm going to add maybe more of those, so we have like more control. And now when I do this, we have basically more detail and resolution. So I'm going to connect the seed to the seed of the attribute randomize and also to the seed of the point instance. Now when I move this thing here, we have different lightning bolts, which are all looking pretty... They are okay already, but this isn't like the quality I'm looking for. This has to be improved a bit. So what we are going to do is that we're going to randomize the scale and rotation also, and then do some alignment as before. So let's randomize the scale, attribute randomize. Actually, this can be afterwards. Doesn't matter actually if that's before or after. Let's randomize the scale. Right here, scale from 0 to 1. We can change the seed here. We can already add a seed controller for this thing so that we have random values each time. And we also need the random rotation. So rotation, a vector, and we're going to randomize the rotation attribute, of course. And the maximum rotation is tau. So this means completely random, 360 degrees rotation. Let's put it here, the controller, and let's drag seed. And you see we have a lot of different stuff, and this doesn't look very good because, you know, these are not aligned to the top. So let's do that. Let's add a align node, align rotation to vector, not align, but align. Align rotation to vector, select the vector, which is, for example, 20 again. On the z-axis can be, I don't know, 10,000 also, doesn't matter too much. And let's select the z-axis. And now let's, you know, change the slider here to for about 0.6, and let's change the random seeds. So now you see we have a lot of different lightning bolts, which are all pretty good, I have to say. We can also move the slider here to select more or less points among those that we have created here. This is basically the lightning bolt. And now here's the question: how do I make this animated? How do I add thickness to it? Well, that's a good question. And we're going to do that using the manipulation of the radius attribute. So if you go here, we have to add a curve to mesh node, because eventually this is going to be a mesh. So curve to mesh and put it here. And as you see, this is now a mesh line. So let's add a circle as the profile curve. You can also add like a star, which would be cool, but you know, a circle works better. A curved circle, of course, not a mesh circle, and put it here, right? So now we have some really massive, like a distorted carrot or a beetroot, something like that. And we don't need too much resolution here. Let's just select 3 and let's turn the radius down to something like that. And as you have noticed, we have lost all of our middle branches. So why is that so? Well, that's because the middle branches are not curves. We have to have curves to convert to mesh. They're already meshes, as you remember. So let's convert them back to a curve and let's disable the point instance before that. So let's select the middle branches here. And let's add a set of geometry nodes here called, what is that? Mesh to curve. And let's add the same system to all of those. So mesh to curve and also mesh to curve. And let's go to the first one and let's really add this mesh to curve node, you know? So mesh to curve. Let's put it here. Let's go back. Basically, these are all curves now. So now if we enable this thing here, the point instance, we have not too great stuff, but basically this looks like a lightning bolt without any thickness manipulation. It looks like some kind of a bush or I don't know, a grass like a plant, something like that. Basically what we need to do is to make sure the side branches are a bit more thin, and also they're getting thinner by the end, and that's the same for the middle one. Actually, it gets thinner by the end. So how do we do this? Well, we have to manipulate the radius attribute. So I'm going to show you how to do this by turning off this point instance first. And now let's go to the middle branches here, and basically we want to have an effect where it goes, you know, thinner and thinner, as you see here. This is basically already infinite, but if you zoom in, it starts to appear, you know, pretty simple stuff. We go here, we have this geometry node system here, mesh to curve. And what we're going to do is that we're going to add a curve to mesh node to see what we're doing. So curve to mesh. This seems like a very dumb thing to do here, like mesh to curve, curve to mesh, but it is necessary. So you're gonna add a circle, a curve circle, and put it here as the profile curve, right? Now, of course, less resolution and a little bit smaller radius, but that's just here for the pre-visualization purposes. And let's use an attribute math node. If we add something to the radius attribute, then I think you know what happens. If you add something here, it gets thicker, right? As you see here, the radius has been made thicker. What we need to do is to make sure we have a thing here that multiplies the radius with a bigger number here and a smaller number here. So we need a gradient basically. So to create this gradient, we can use the length of the object vectors. And what are the length of the object? What is the length of the object vectors, you're asking? As you see here, this is the origin point, right? And to each vertex, for example, this one here, we can draw a little vector, like a very tiny baby vector, which has a certain length, right? Then we can draw one to here. And we can also draw one to a vector around here, to a vertex around here. So basically, we can draw a vector to each vertex. So this means we can get their length. And this is a gradient, because this is smaller here and quite big up here. We just have to invert this, right? And this is basically the solution to our problems. So let's do this. Let's add a vector math node because we're dealing with vectors, attribute vector math. And let's set it to the length operation. And let's take the length of the position of each vector. So the length from the object center to the position of each vector. And let's call this an attribute called length. So now we just have to multiply the radius with that length attribute. So let's go here, let's select the length. And look at that, we have something completely random and messy. No, not completely random, you know, this is it is basically the thing that I just explained, but you know, we have to invert this. How do we actually invert this? We don't have an invert node here, you know, this isn't here. We need to have a subtraction node. Duplicate this attribute math and let's set it to subtract. And down here, let's subtract from a float the length attribute resulting in length. And now you're asking, how is this possible that it works like that? How can we invert things like that? This is pretty simple. So you see down here, we have the length of 0, right? Pretty much 0. And if we subtract from 0 the length of 0, rewriting this here to a new attribute, and then we're going to multiply this with radius, then of course the radius is going to be 0 here. So if I put here, for example, 4, then here we're going to subtract from 4, 0, which means 4. So we're going to multiply the radius by 4. And up here, here we have the length of 4. 4 minus 4 is 0, so the radius gets multiplied by 0, which means no radius at all, right? So we can use this to subtract the things here. Up here we have negative values and we have to get rid of those, which I'm going to show you how to do this in a second. So let's move this to a reasonable place up here somewhere. And let's now clamp this. So clamping means just removing a range of values that we don't want to. So let's clamp the length attribute like that. The maximum value is 1 and the minimum value is 0. So you see we have something like that. We can change like the position of these things, and this is good and all, but actually this doesn't look very good. And that's because the fall off is extremely sharp up here. So we somehow have to make it a bit more soft. And for that we can use the division node. So let's take the divide and let's divide the length with a random float. And you know, if we do something like that, then we can change how soft or hard this actually is. So something like that, and I think this works pretty well. Now this is done. Let's turn off this curved mesh here and the curved circle, hide them, and let's go back here. And let's enable the point instance. So if you look at this now, you see we have like a quite nice lightning bolt, don't you think so? But the problem is that the middle branch isn't thinking of getting a bit more thin. It is very thick. So how do you make this thing a bit more thin? Of course, the same way as we did with the middle branches. So we go to the middle branches here and we select one of those. We select all the nodes that we used here. So like that, command copy or control copy if you're on Windows or Mac or whatever. And we paste them here. Okay, now they're here. And let's just, you know, this is our original lightning bolt. Let's just connect it to the geometry. Let's turn off this thing here with control drag. And let's go here and connect this to the end join geometry. So now you see it is getting a bit thinner in the end, which is pretty good, I think so. Maybe we just have to change the, yeah, so something like that. Maybe the fall off, something like that. This works, right? So now let's add the point instance node, and this is looking like a lightning bolt, and we can change the seed. Let's rotate this actually. This is pretty similar to what we have on the picture. Maybe this is a bit too crowded, but that is because, you know, the middle branches I chose were a bit too detailed. So what we're going to do now is that we're going to add the animation, and this is going to be exciting. So as you remember, the animation worked like that. You just are going to make this a bit smaller or bigger. So how does this work? As you see from the side, this looks suspiciously like a circle that is getting smaller, right? This means, at least to me, object vectors have something to do here. So let's go here and let's do so that we multiply the radius attribute with the object vectors, the length of the object vectors. So before we actually make it a mesh, of course, and let's go here and let's add a vector math node to get the length of the vectors, attribute vector, not a rotate, attribute vector math, put it here and let's select the length. And of course, length of the position resulting in attribute of length. We're just overriding the previous length attribute. And now let's add an attribute math node, like a normal attribute math. And let's put it here and let's multiply the radius with the length attribute resulting in the radius. So you see, this is pretty heavy, right? This is like when the lightning hits the sand, you have things like that. I haven't found nothing like that personally, but I have seen pictures, so I'm gonna show you one as well. But anyways, what we have to do is to, of course, make it a bit more weak, this effect here, and also invert this. So let's go here and invert this as we did before. So we are gonna subtract from a float the length resulting in length. And as you see, now we can change the appearance of it. So let's put it somewhere here, like that. And now let's add a clamping node so that we actually get rid of those negative values down here. So let's add a clamp node, attribute clamp, and let's clamp the length, and the result is the length, of course. So right now I can animate this like that, and this doesn't look very good, to be honest, right? The fall off is obviously too sharp. You know, this doesn't look good, just as simple as that. So to actually make it appear better and not so boring, as you see here, with the original one, I have made a system where it gets a bit thicker before it actually, you know, appears. And this can be done with a logarithm, which is a very good mathematical operation, turns out. So basically, you need to go, you know, you have a vector length subtracts attribute clamp. You're gonna add a logarithm after that. So logarithm, and you're gonna take the logarithm of the length attribute as the base is gonna be a float, a random float like that, like 34. And as you see, you have appearing things like that. So this is actually physically correct. And before lightning strikes, you always have these kinds of like things appearing in the air. So, and you can have like two lightning bolts. One of them creates these kinds of things before, and the other like strikes after that. It's up to you. But I'm just gonna like fuse them together. And to do that, what I'm gonna do is that I'm gonna drag this maximum clamping value here a bit down. So for about 0.5. And now I have this lightning bolt that has some thickening before it actually strikes, and this does look a lot better. At least that's what I think. If you want to now control the overall like radius of this thing, you can select this curved circle here and make it a bit thicker. So if that's what you're looking for, that's good. If you want to make sure that your, you know, side branches are less thick than the center one, then you just have to go where your side branches are. So here, right? And you are gonna select the multiplication node, or add a multiplication node, and multiply the radius with a float. So for example, like that, you have more, and I'm gonna put here like 0.7, then I have less thickness for the side branches, right? So this is basically how everything works here. We just have to add a control for the subtraction here, and now we have also the animation control, as you see, from here to there. So okay, now it's for the materials. So let's go to select this object here, and in the end add an assign material node, right? Material assign, and you're going to go to the material tab and add a new material called lightning bolt, and let's select the lightning bolt material from here, right? So let's go to the shading tab right now. So as you see from the reference, the lightning has a brighter thing in the center and not so bright things on the sides. So how do we fake this? Basically, well, for that, we just have to have a texture coordinate node. And if you look from the top, we basically want to have more brightness here in the center of the object, basically. We want to create around the origin some brighter things, right? So to do that, let's take these texture coordinates and let's add a vector length node, vector math, object coordinates. Let's take the length of them and let's use this as the brightness. So not anything too good. Let's use a math node and the greater than to compare it. And as you see, you know, we have some values coming from the top like that. But we don't want a sphere like that. We want a cylinder coming, you know, up and down along the whole lightning bolt. So we do that with a mapping node. So we add a mapping, put it here and scale it on the z-axis with 0. So right now this is a cylinder like you see here. So when I look from the top, you see I have a cylinder here, right? So I can use this as the brightness of an emission shader. So let's add an emission shader. Let's connect not the greater than, of course, but the value to the strength. And let's add a color ramp. So color ramp, and we can, you know, change the fall off basically. And if this isn't enough for you, you can add a math node before. So like that, and multiply it with a little, you have to invert those, of course. So something like that, and with a B-spline maybe. This seems to be working nicely. And now let's multiply this in the end with, let's say, 20, and this is now bright in the center and not so bright on the sides, as you see. We can also use this as the color, so let's add another color ramp, put it here, and connect the same value to the colors, and connect this to the color. Let's change one of them to something very blue. Okay, the center color, something like that. And the sides can be also something bluish, but not too much. So this is how the material works. As you see here, it has a different color in the center and maybe should be a bit more. This works better. At least that's what I think. So this was the tutorial. I hope you enjoyed this. It was actually pretty fun to make. And these lightning bolts are also used in a music video of whatever in that shot right here. So these are a pretty commercially viable assets. So I hope you learned something useful. See you next time.